The last of the nonspecific responses to pathogens that we're going to talk about is fever. Now, fever is a temporary increase in body temperature. And the way it happens is that macrophages and neutrophils, when they do phagocytosis of bacteria or in virally infected cells, they secrete something called pyrogens. I sometimes think of this as eating and then the neutrophils or macrophages burping afterwards, and that's what's in the burp. These pyrogens travel through the bloodstream until they reach your hypothalamus, because the hypothalamus is where our body temperature is set. And it causes the hypothalamus to change the set point for body temperature to a new higher temperature. And then that becomes the set point, at least while the fever is in process. Now, this uses something called prostaglandin as a signal, and prostaglandins are inhibited by things like Tylenol, ibuprofen, and aspirin. So when we take those when we have a fever, it interrupts this signal and causes the set point in our hypothalamus to go back to the normal setting. It interrupts this. Now, the reason that we don't want the fever to be interrupted is because it's actually a very effective defense against pathogens. One of the things that it does is it causes the body, or causes the liver, to hoard zinc. Hoard means to hold onto and not share. So the liver hoards zinc. Well, it turns out bacteria need zinc in order to replicate. So by taking all of the zinc and putting it away in the liver where the bacteria can't reach it, we put the bacteria at a disadvantage, which means that we have the advantage in terms of fighting the bacteria off. The other thing, or another thing that fever does, is it promotes interferon activity. Interferons, remember, are secreted by virally infected cells, and they tell other cells to protect themselves, as well as attract natural killer cells to the site to help fight the infection. So this makes it a lot easier for our immune system to fight viruses if the fever is present. Incidentally, the interferons, when they are secreted throughout your body, that's what gives you the really achy muscles that you get when you have a fever. So if you're feeling those achy muscles, you can at least rest assured that your body is busy working on a viral infection. The last thing that fever does, but is still important, is that it increases the metabolic rate. So by increasing the metabolic rate at the same time that we've put the pathogens at a disadvantage, we give our immune system the advantage in terms of being able to reach the site of infection quickly, to be able to respond to the infection quickly, and to be able to recover from the infection quickly. So these are the three very important things that fever does. Now, how does it look? We've all had fevers before. Fevers always start with something called onset. Onset is when you feel super cold and you're shivering even though everyone around you is comfortable. So what happens is, if you look at this black dotted line, this represents the set point for body temperature. So before you have a fever, your set point is down here. But when the pyrogens are secreted and the hypothalamus changes the set point, that dotted line moves up here. For a brief period of time, your body temperature is lower than the set point. And if your body temperature is lower than the set point, you feel cold because you're not where you're supposed to be, or where your brain thinks you're supposed to be. So this is called onset, and this is when we say someone has the chills. Now, once the body temperature reaches the new set point, you actually don't feel chilled or hot. You feel sick. But your body temperature doesn't feel wrong. We say that this is stadium. So this is a steady point in the middle of the fever process where you are maintaining your body temperature at the new set point. Now, once the infection's taken care of, the neutrophils and the macrophages are no longer phagocytizing bacteria, they're no longer producing pyrogens, and therefore the set point of body temperature can return back to its normal setting. For a brief period of time, your actual body temperature is higher than the set point, so you feel hot and you sweat. And this is what we call the fever breaking, though its fancy scientific term is defervescence. So chills when the fever is onset or beginning because your body temperature is lower than the set point. No chills or sweating during stadium because you are at the body temperature your body thinks you should be at. And then when the set point returns to normal, there's a period of sweating where your body temperature returns to the regular normal set point.